Here is a two-voice original combination composed by Sergei Taneev. And here is a derivative combination brought about by a transformation of the same two voices. In the last video, we examined vertical shifting counterpoint. But here, neither voice has been transposed up or down in the scale. Instead, the voices have shifted their timing in relation to one another. Taneyev referred to this as horizontal shifting counterpoint. In horizontal shifting counterpoint, Taneyev labels the voice that occurs first as uppercase Roman numeral 1, and the voice that enters later as uppercase 2. Compared to the original, voice 2 of the derivative has been horizontally shifted to begin one measure earlier. Taneyev would indicate this by a superscript h, representing a horizontal shift, equal to -1. 1 in this case refers to the number of measures that have been shifted, and it can take a fractional value. The value is negative because voice 2 has been shifted earlier in the direction of voice 1, very much analogous to what we learned in the video on vertical shifting counterpoint. In this case, the voices have switched positions so that voice 2 now begins before voice 1, which Taneyev would refer to as an inverse shift. And just as in vertical shifting counterpoint, this new type of counterpoint also has a horizontal shift index, JH, which is the sum of the horizontal shifts of the two voices. We could have equally said that voice 1 was shifted one measure later compared to the original. Unlike in vertical shifting counterpoint, there is no scale to use as a reference in figuring out which voice is moving and which is sitting still. But the relative motion between the two voices, the horizontal shift index, would be the same in either case, and this is the important value. Okay, well, this example happened to work shifted at one measure, but I can imagine a lot of two-voice themes that would produce contrapuntal nonsense if the voices were shifted horizontally at random. How can we compose an original combination that will produce a contrapuntally correct derivative at a horizontal shift? Taneyev calls his solution a basic version. In the basic version, one of the voices is shown in canonic imitation with itself. The leading voice of the canon, Taneyev refers to as the proposta, and the following voice of the canon is the risposta, propose and response. Notice that this particular canon is not well formed. That is to say, the two voices do not form a contrapuntally correct combination. There are a number of dissonant intervals that are not correctly treated as passing tones or suspensions. Since this canon does not form correct counterpoint, one of the voices must be considered imaginary, a voice that is written down in the notation but not sounded in performance. Taneyev indicates imaginary voices using an ellipsis, and in this case the risposta is the imaginary voice. For clarity, I will also place the note heads of imaginary voices in parentheses. Taneyev's very clever idea is to now compose a counterpoint melody, which he would abbreviate CP, that will form correct two-voice combinations with the proposta and with the imaginary risposta independently. As I mentioned earlier, the proposta and imaginary risposta do not form a correct combination, and therefore the whole three-voice texture will also not form correct harmony. But like Meatloaf sang, 2 out of 3 ain't bad. And there is a surprising amount of work that can be accomplished using an imaginary voice in a basic version. Here's the countermelody that Taneyev composed. Think of this step as composing a florid countermelody against two cantus firmi simultaneously. From this basic version, we can extract the proposta and counterpoint to form the original combination that we saw a moment ago, and the counterpoint and imaginary risposta to form the derivative combination. Because the canon had a distance of entrance of one measure, the horizontal shift index of the derivative is -1, and JH will always be equal to the distance separating the canonic voices in our basic version. Now let's look at a slightly different example from Palestrina. And here is the derivative combination. In this example, voice 1 has been horizontally shifted to occur 2 measures later and vertically shifted up 2 steps of the scale. The vertical shift is given as a superscript and the horizontal shift as a subscript. Taneyev refers to derivative combinations related by both vertical and horizontal shifting counterpoint as double shifting counterpoint. Composing double shifting counterpoint also involves constructing a basic version with canonic voices and is no more difficult than composing horizontal shifting counterpoint. Here's the setup for the basic version of this example. The risposta follows the proposta at a distance of entrance equal to the horizontal shift index, in this case 2 measures. The risposta also follows at a directed interval of entrance equal to the vertical shift index. In this case, the notes of the proposta are transposed upward, directed away from where the counterpoint will be composed, by 2 steps of the scale. If the vertical shift index were negative, the risposta would have to follow 2 steps lower, directed towards the countermelody. And here is Palestrina's counterpoint melody. Taneyev makes it a rule that if there is a contrapuntally correct arrangement of the 3 voices, as proposta, risposta, and counterpoint, then that version is the one that should be taken as a basic version. In this case, all 3 2-voice combinations work in correct counterpoint, and so none of the voices need to be interpreted as imaginary. Notice that the canon works only in the upper voices, since the proposta and risposta form fourths that are treated as imperfect consonances, which would not be possible in an isolated 2-voice texture. Those voices need the counterpoint voice below, forming consonant support for those fourths. Contrapuntally correct basic versions are very useful in composition. The beginning of this Benedictus movement by Palestrina seems remarkably complex at first sight, but can be analyzed easily once we have uncovered the basic version. The tenor begins with theme 1, which I will highlight in blue, while alto 2 takes a countermelody, theme 2, in red. The bass then enters with theme 2, while the other voices continue in florid counterpoint. Then things start to get complicated. Alto 1 enters with theme 1, and the bass imitates alto 1, forming a canon at the lower octave at a distance of 1 measure. At the same time that this canon takes place in the outer voices, alto 2 then takes up a transposed version of theme 2. Finally, tenor 2 and alto 2 demonstrate how theme 2 also works as a canon at the upper fifth at a distance of entrance of 1 measure. So, was Palestrina just lucky that his themes happened to work out this way? Mostly no. Palestrina actually did not compose what I've referred to here as Theme 1. That is a snippet of plain chant after which this mass was named. Palestrina must have noticed that this plain chant works in canon with itself at the lower octave, and used this as the basis for a basic version. He then composed a counterpoint that works as a correct three-voice texture accompanying the canon. In traditional counterpoint pedagogy, these sketches are sometimes referred to as a draft page, or Entwurf in German, which is the word that I mentioned Albrechtsberger using in the video I made on perpetual canons. Taneyev claims that the composition process is now quite simple. Palestrina composes this basic version, which is the most complex, and then works backwards to compose the entrances of the other voices to lead into the presentation of this basic version. Palestrina introduces the first two voices with the risposta counterpoint combination, since this introduces both themes, and beginning with the proposta counterpoint combination is not possible, since the perfect fourths in this combination require consonant bass support, and at this point there are only two voices in the texture. The bass then enters with the counterpoint, while the other voices continue in florid counterpoint above. Then, with the entrance of alto 1, we finally get the basic version. The tenor continues in florid counterpoint, filling in the missing thirds from these incomplete triads in the basic version. Then Palestrina also tacks on a canon for the counterpoint, leading to a cadence. From the listener's point of view, there's an exciting increase in complexity over the course of this exposition, but from the composer's perspective, he simply wrote the hardest part first and worked backwards from there. Basic versions and imaginary voices are extremely useful in composing imitative counterpoint, and they are hardly explored at all in the counterpoint literature prior to Taneyev. It is his most original contribution to music theory. The rest of this video will explore only some of the compositional applications of basic versions and imaginary voices. Let's say we wanted to compose a florid countermelody against a given cantus firmus. Let's use Fuchs's Dorian cantus firmus, Old Faithful, as our given melody. One of the rules of species counterpoint is that students should not include repeated motives and melodic sequences. That type of repetition goes against the spirit of the exercise, although, of course, melodic sequences and motivic repetition take place all the time in real music. What if we wanted to compose a countermelody for the first 6 measures that could be repeated verbatim over the last 6? This cantus firmus is 11 measures long, so there's no way to evenly divide it. To solve a problem like this, we simply need to employ an imaginary voice, specifically an imaginary copy of the cantus firmus, and the problem becomes one of horizontal shifting counterpoint. By the way, if you are interested in reading more about this type of compositional problem, I can highly recommend this article by Peter Schubert, who converged on the same solution coming from a completely non-Taneyev angle a few years ago. What we need to do is copy and paste the last portion of the cantus firmus alongside the beginning as an imaginary voice. The cantus firmus and imaginary cantus firmus in this case happen to form correct counterpoint, moving exclusively in thirds. But as we saw earlier in the video, this does not need to be the case. We could have incorrectly treated dissonances, parallel fifths, all sorts of stuff, and still be able to use it as an imaginary voice. Now all I need to do is compose a countermelody that forms correct counterpoint with the first 6 measures of the cantus firmus and, independently, the imaginary cantus firmus. I came up with this solution, although I took a small liberty with this suspension resolution. Now when we write out the repetition of the countermelody over the last 6 measures, it will form the same counterpoint with the cantus firmus as the first 6 measures did with the imaginary cantus firmus. This exercise sounds like this. What if we wanted to compose a transposed sequence? The solution here involves double shifting counterpoint. Let's say I wanted to compose a theme over the first 5 measures that will work over the final 5 measures transposed up 4 steps of the scale. In other words, up a fifth, sort of like a fugue subject and answer. All we need to do now is overlay the final 5 measures of the cantus firmus on top of the first 5, but transposed down 4 steps of the scale. Next, I composed a countermelody that works over both versions of the cantus firmus for the first 5 measures. Then I transposed that countermelody 4 steps higher over the final 5 measures. And finally, I composed a short passage that connects the 2 statements of the theme. I can highly recommend exercises using various kinds of melodic sequences as a next step after mastering 5th species florid counterpoint. It teaches how to think in terms of imaginary voices, horizontal and double shifting counterpoint, and as we will see in a moment, it also teaches the rarer kinds of vertical shifting counterpoint. It was known for centuries predating Taneyev that an exercise composed in invertible counterpoint at the 10th, such as this one composed by Heinrich Bellermann, will also work as a 3-voice texture when one of the voices is doubled in parallel tenths. Taneyev called this duplicating counterpoint, and he distinguished it from vertical and horizontal. But the reason this 3-voice texture works in correct counterpoint has to do with the interval of a tenth. Parallel imperfect consonances are permitted in counterpoint, while parallel perfect consonances and dissonances are not. However, the logic of this example applies to other exercises in invertible counterpoint as long as one of the voices is considered imaginary. We can set up a counterpoint exercise with the cantus firmus in parallel 12ths, for instance, and as long as we understand that one or the other version is imaginary, then we can use this setup to compose invertible counterpoint at the 12th. I like to think of this as a basic version from double shifting counterpoint, but one where JH happens to be 0, so that all that is left is the vertical shift that we intend to study. Now, when I compose a countermelody that works below one version of the cantus firmus and above the other, it will by definition be written in invertible counterpoint at the 12th. Here is the countermelody that I wrote. Notice that all of the constraints of this particular vertical shift index, which we looked at in the previous video, are present in this basic version without actually going through all of the mathematical steps that Taneyev describes in the first part of his book. The 5th of the original combination, for instance, inverts into an octave in the derivative, and this will be true for every corresponding pair of intervals. The variable dissonance of a suspended 7th above in the original combination must conform to the limitation of Taneyev's X symbol, since the tone of resolution will invert into a dissonance in the derivative. And yet, all of these technical problems and their solutions can be encountered and resolved by a musician trying to weave a counterpoint between the 2 cantus firmi. Don't get me wrong, Taneyev's math and symbols and charts are still quite useful for forming generalized proofs, but pedagogically, I think this type of basic version is all that a student really needs to practice vertical shifting counterpoint at any interval. The surprising thing is that whatever the interval is separating the imaginary cantus firmus from the real cantus firmus, that is the vertical shift index that limits the voice leading of the counterpoint for that measure. As a shorthand, I refer to these vertical intervals as guide intervals. In this type of setup, which is effectively a canon with no time delay between the leading and following voice, the guide interval is the same in every measure, in this case a 12th. But if you go back and watch this video from the beginning, you will notice that in those other basic versions, the guide interval changes from measure to measure, and yet that interval always determines the kind of vertical shifting counterpoint that governs each measure. Here is what my countermelody sounds like in combination with the lower cantus firmus. And here it is in combination with the upper cantus firmus. Another practical use of imaginary voices is composing fugue subjects that work in multiple strettos. Let's say we wanted to compose a Dorian mode fugue subject, beginning on D, that works in stretto at the upper fifth at a distance of 1 measure, and also in stretto at the lower fifth at a distance of 2 measures. Here we are effectively dealing with a 3-voice canon, with proposta and 2 rispostas. I'm going to consider risposta 2 to be the imaginary voice, since it does not need to form correct counterpoint with risposta 1, and the whole 3-voice texture does not need to form correct voice leading either. In measure 2, the only constraint we need to worry about for the composition of our proposta voice is that it work in counterpoint below the note A of risposta 1, like a given note of a cantus firmus. Let's choose the note F, forming a third below. This choice determines the note C for risposta 1 in measure 3, and the note B for risposta 2 in measure 4. The choice of note for measure 3 is now doubly constrained, in other words, double counterpoint. It needs to form correct 2-voice counterpoint both above the note G and below the note C. If you wanted to, you could construct an interval table for invertible counterpoint at the 11th, to show how each interval will invert within this measure. For invertible counterpoint at the 11th, or JV equals -10, the only fixed consonance is the 6th, so we can choose the note E for this measure, which also determines the next notes of the 2 risposta voices. Finally, the proposta note for measure 4 must work in invertible counterpoint at the octave, above and below the note B in the 2 risposta voices. Our starting note D will work. Some of you might recognize this fugue subject from Fuchs's Gradus ad Parnassum. It is the first 4 notes of that famous cantus firmus. He uses it in all of his Dorian mode demonstration fugues in the last section of the book, and he always uses both strettos. I analyzed those fugues in previous videos, so I'll just link to them here instead of rehashing all of that. Just like Palestrina, in the example we looked at the beginning of this video, Fuchs places the simplest contrapuntal versions first, and then gradually reveals greater complexity as the composition progresses. He begins with the fugue subject without any strettos in the exposition. Then in the middle entry group, he uses the looser 2-measure stretto, which sounds like this. And then, finally, near the end of each fugue, he uses the tight 1-measure stretto. Using a draft page to compose a fugue subject that contains contrapuntal tricks that are gradually revealed over the course of the composition is a very good idea. If you're going to tell a joke, you need to know the punchline beforehand. Finally, let's look at how imaginary voices can be used to analyze horizontal and double shifting counterpoint in real repertoire. Here is the fugue subject from the Fugue in B major from Book 2 of the Well-Tempered Clavier, as it is combined with a new countersubject in measure 27. This can be considered the original combination. I've already discussed this countersubject in the video on fugues written with invertible counterpoint at the 12th. Here, though, we can return to it using Taneyev's terminology. In measure 42, voice 1 is shifted down 4 steps of the scale, while voice 2 is shifted up 7 steps compared to the original, producing JV equals -11, or invertible counterpoint at the 12th. What I did not mention in the earlier video is that this countersubject also works in double shifting counterpoint, which Bach demonstrates starting in measure 60. Compared to the original, voice 1 has been vertically shifted up 3 steps and horizontally shifted back 1 half note, or half a measure. Voice 2 has been shifted up by 1 step, therefore JV equals 2, and JH equals -1/2. We can analyze this transformation by constructing a basic version. The fugue subject is the counterpoint in the lowest voice, and the countersubject forms a canon at a distance of 1 whole note and at the lower third, with proposta and imaginary risposta. Notice that wherever the proposta and imaginary risposta of the canon form parallel unisons with one another, the two voices end up forming the same intervals against the lower voice. In other words, JV equals 0. Since neither the original nor derivative combinations contain the interval of a sixth, both will work in invertible counterpoint at the 12th, which we've already seen Bach exploit during the fugue. There is much more to be said about horizontal and double shifting counterpoint, especially with respect to canon writing. That is mostly the domain of Taneyev's second book, The Doctrine of the Canon, which was published posthumously. I plan on getting into that in future videos, but in the next one in the series, I want to share how to compose canons against a cantus firmus, which was the subject of a recent publication of mine.